Imagine tossing a bottle into the ocean, carrying a message about who we are. Now, picture that ocean as the vastness of space and the bottle as Voyager 1, a machine launched from Earth, now farther than anything we've ever built. Voyager 1 carries a golden record, a mixtape of Earth's sights and sounds, just in case something finds it in the cosmic sea. Its journey has been epic past gas giants, volcanic moons, and into the unknown, but its most profound discovery came as it left home, a boundary not of stone but of energy, separating our solar system from interstellar space. Scientists call it the Wall of Fire, not flames but a sizzling, superheated frontier, the sun's final handshake before true darkness. This isn't just trivia, it redefines our place in the universe. Our solar system is a bubble, carved out by the sun, with a real edge. The heliopause, the Wall of Fire, is the skin of that bubble, the gatekeeper to the galaxy. Understanding it is crucial if we ever hope to become an interstellar species. Voyager 1's story is our story, a quest to cross boundaries and explore the unknown. So, what is this wall? Why is it there? And what does it mean for our future? Let's follow Voyager's path and unravel the science behind this incredible phenomenon. All you need is curiosity. The universe is our laboratory and Voyager is our scout. Its discovery reminds us, the cosmos is more complex, dynamic, and awe-inspiring than we ever imagined. Let's rewind to 1977. NASA launches Voyager 1 and 2, seizing a once-in-176 years planetary alignment. This grand tour let the probe slingshot from planet to planet, saving time and fuel. Voyager 1, launched second but faster, was tasked with close-ups of Jupiter and Saturn. It revealed Jupiter's storms, the Great Red Spot, and active volcanoes on Io, proving other worlds are alive. Its images transformed distant dots into dynamic worlds. At Saturn, Voyager 1 unveiled the planet's intricate rings and Titan's thick, mysterious atmosphere. Studying Titan meant skipping Uranus and Neptune, but the data was invaluable. With its planetary mission complete, Voyager 1 was flung out of the planetary plane, beginning its interstellar journey. Its new mission became the first human-made object to enter interstellar space. For decades, it sailed onward, its instruments measuring the unknown. The farther it went, the colder and darker it became. But it was heading for a boundary no one had ever measured, a place where the sun's influence ends. Voyager 1 was on course to cross into the galaxy itself. The stage was set for a historic encounter. Voyager 1 traveled through the heliosphere, a giant magnetic bubble blown by our sun. The solar wind, a stream of charged particles, fills this bubble and pushes against the galaxy's material. As Voyager moved outward, it noticed the solar wind slowing, like a speedboat hitting thick water. This was the termination shock, where the solar wind drops from supersonic to subsonic. Voyager crossed it in 2004, entering the turbulent heliosheath, the sun's final buffer zone. Here, magnetic fields twisted, particles fluctuated, and Voyager surfed the solar system's chaotic edge. Scientists watched, knowing the final boundary, the heliopause, was near. In August 2012, the data changed. Solar particles dropped, galactic cosmic rays spiked. The solar wind vanished, galactic winds took over. After 35 years, Voyager 1 had crossed the heliopause and entered interstellar space. It was the first object from Earth to do so, a monumental achievement. The probe's journey turned theory into reality. Voyager 1's crossing marked humanity's first step into the galaxy. The data it sent back changed our understanding of the solar system's edge. The boundary was real and we had finally touched it. The cosmic frontier was no longer just a concept. It was a place we had reached. The heliopause is the edge of our solar system's influence, a cosmic tug-of-war between the sun and the galaxy. It's not a neat line, but a dynamic, fluctuating region, shaped by solar activity and our movement through the galaxy. The sun's bubble is compressed into a teardrop, with Voyager 1 exiting through the blunt front. The heliopause's existence was long theorized, but Voyager 1 provided the first direct evidence. Its data let us measure the boundary's thickness, pressure, and magnetic interactions. The heliosphere acts as a giant shield, deflecting about 70% of dangerous cosmic rays. These high-energy particles threaten life, so our sun's bubble is a protective cocoon. The heliopause is the outer layer of that cocoon. Understanding it helps explain how life flourished on Earth. It's our first line of defense against cosmic radiation. Voyager 1's crossing turned a mathematical idea into a real physical place. The boundary is crucial for our survival and our dreams of exploring beyond. The data from Voyager 1 is a treasure map for future explorers. The heliopause is both a shield and a challenge. At the heart of the heliopause, Voyager 1 found something startling: a wall of fire. The plasma here was measured at 50,000 Kelvin, 10 times hotter than the sun's surface. Plasma, the fourth state of matter, is a soup of charged particles, electrons and ions. Over 99% of the visible universe is plasma stars, solar wind, even the interstellar medium. But this fire isn't like flames on Earth. It's a fire of temperature, not density. The plasma is incredibly thin. Particles are millions of miles apart. You wouldn't feel the heat. You'd freeze in space long before sensing it. The temperature measures particle speed, not how hot it feels. At the heliopause, particles move at mind-boggling speeds. But there are so few, the heat is ghostly. It's a fire of pure energy and speed, not substance. Voyager 1's instruments revealed this invisible inferno. The wall of fire is a cosmic phenomenon, not a barrier of flames. Why is the plasma at the heliopause so hot? As the solar wind slams into the denser interstellar medium, it slows and compresses, creating shock waves and turbulence, like a cosmic traffic jam. Compression heats the plasma, just as a bicycle pump gets warm when you use it. Magnetic reconnection, where solar and galactic magnetic fields snap and rejoin, releases bursts of energy, superheating the plasma. This is plasma physics on a grand scale. The wall of fire is a natural result of these forces. Voyager 1's sensitive instruments measured the particle speeds, letting scientists piece together this story. A tiny probe solved a giant cosmic puzzle. Voyager 1 sailed through the 90,000-degree wall of fire without melting. Because the plasma is so thin, the heat can't transfer. The real danger is radiation. The heliopause is where the sun's shield is weakest, and galactic cosmic rays bombard the probe. Voyager's old-school electronics are surprisingly resilient, but glitches and data corruption are constant threats. For humans, the radiation would be lethal, far beyond anything faced in Earth orbit or on the Moon. Shielding astronauts would require immense, heavy protection, making interstellar travel even harder. Voyager 1 proved a machine can survive, but highlighted the biological challenge for us. The wall of fire won't burn you, but its radiation could kill. The heliopause is a test for technology, and a warning for future explorers. Surviving the crossing is just the beginning. The heliopause is the first great barrier to interstellar travel. Voyager's data shows leaving the solar system is more like braving a storm than sailing into calm seas. To cross safely, we need propulsion far beyond today's rockets: fusion, antimatter, or even theoretical warp drives. Radiation shielding must be light yet powerful, perhaps active magnetic fields to deflect cosmic rays. Medical advances will be needed to repair radiation damage. Interstellar ships must be autonomous and self-repairing, as communication delays will be years. The heliopause is just the first test. The space between stars may hold even greater dangers. Voyager 1's journey reveals the scale of the challenge, but it also shows us what's possible. The dream of reaching the stars begins with understanding and overcoming this barrier. Voyager 1's story is about curiosity and pushing boundaries. Its discovery of the heliopause didn't stop us. It gave us a map and a challenge. Every age of exploration began by understanding its barriers. For us, the heliopause is our first cosmic chart. Voyager's data inspires new generations to solve the problems of interstellar travel. Its mission reminds us of the power of looking outward, uniting us in a quest for discovery. The probe's faint signal, over 15 billion miles away, is a gift to humanity. One day we may build ships to follow Voyager's path, mastering the challenges it revealed. When that day comes, it will be thanks to the visionaries who sent Voyager out. The journey has just begun. The universe is waiting. Let's get to work.